An example, here we are displaying the large letter T using the character T. Another example is a shape that consists of the @ character. And the last one in this example is a shape that consists of the character asterisk or a star. Now, if you want to use nested loops to display such shapes, then you need to look at each shape that is a grid of letters. So here is an example for the letter T. We can assume that this shape is displayed as a grid of 5 rows and 5 columns. 1, 2, 3, 4, 5 rows. 1, 2, 3, 4, 5 columns. So if I want to display this shape using the letter T, then I need to display the character only in the first row and in the middle column. Now for the other shapes, we have to look at displaying such characters this way. For example, in the middle, if I want to display this shape using the @ sign, then notice that the @ sign is on the main diagonal of the shape, also on the right diagonal, and in the middle row of the shape. Now if I want to go for the last shape, as you can see that the asterisks are displayed on the corners. So this corner is at row 1 and column 1, and this corner is at row 1 and column 5, which is the last column. And this corner is at row 5, which is the last row, and this corner is at row 5, which is the last row, and column 5, which is the last column. So as you notice that in this grid, if you want to design nested loops, you have 2 letters to display or 2 characters to display. The character T or the space. And here the character is @ or a space, and here the character asterisk or the space. So how to design nested loops to display such shape? Here are the nested loops. So we have an outer loop and we have an inner loop. Both of them are for loops. The outer loop is responsible for the number of rows, and notice that the index variable for the loop we are using is called row, and the inner loop is responsible for counting the number of columns, and as you notice that the index variable for the loop is called COL, which is short for column. Now when row is equal to 1, then the inner loop will consume all the iterations from 1 for the columns up to 6. So it will go over the columns from 1 to 6. Now when row is equal to 2, again the inner loop will be repeated, and again it will start over from column 1 up to column 6. In each iteration of the inner loop, as you notice, it is printing the symbol or the character. And here we are using asterisk. And notice we are using a print, not a println, so we need to print all these asterisks on the same line. After the inner loop for row 1 is consumed, then it will go to the next statement in the outer loop, which is printing a new line. So that means it's going to jump to the next line. When row is equal to 2, then again the inner loop will be repeated for column 1 up to column 6. So let me show you how this works. Now, when row is equal to 1, then the inner loop will start printing all asterisks on row 1, because a print is inside the inner loop and it is printing on the columns 1 to 6. So this is column 1, column 2, column 3 up to 6. In each iteration, it's going to print an asterisk. Now, when we go to the next iteration for the outer loop, when row is equal to 2, again the inner loop will be repeated, and it will go over all columns from 1 to 6. And in each iteration, it will print an asterisk, and this is how it's going to work. So it's going to print the second line. Now, for the third iteration of the outer loop, it is going to display the third row. And for the fourth iteration of the outer loop, when row is equal to 4, it's going to print row number 4. And when row is equal to 5, then the inner loop will print all asterisks on row 5. And last, when row is equal to 6, which is the last iteration for the outer loop, then the inner loop will print all asterisks on each column, and this is how it's going to work. So as you notice that this inner loop is printing row by row, and it is printing only one shape, which is the asterisk. Now, if I want to display a shape of symbols, but we don't want to display on all cells inside this grid with asterisks, then we have only 2 characters. Either we display the symbol star, or we display a space if we don't want to display anything in that cell. Our next question is how to modify these two nested loops and display any shape of any character. Now we have already understood that these two nested loops print the characters row by row. So first we print the characters at row 1 and at row 2 and etc. We can look at these rectangles as cells of a grid. The size of this grid is 6 rows and 6 columns. For example, I can look at this star or asterisk that it is in cell row 1, column 1. I can look at this asterisk that is at row 4 and column 5 and so on. So if you want to display a shape of any character, then you need either to display that character or you display a space in this cell. So what we need to do, we will remove this print statement because this is always printing the star, and we will replace it by an if statement. And we are going to have two print. One is printing the star and one is printing a space. In any cell, if we want to print an asterisk, then we need to locate its location and see where is it exactly, and then we put it under the condition for printing the star. And if we want to print a space, then we put that condition under this the statement that is printing a space. For example, if I want to display all stars that are on column 1, so on all rows, but specifically on column 1, so the condition will be column equal to 1. Now suppose I would like to display all stars that are at the last row, regardless of what is the column. Then we can put a condition that says row is equal to 6 or n if the last row is saved into a variable that is called n. So let us go for an example to show you exactly what we mean by replacing the print statement inside the inner loop by a conditional statement. In our first example, we would like to display the letter n, large letter n, using a grid of size 6 rows and 6 columns. And this is what we need to display for the large letter n. To display large letter n in a grid of size 6 rows and 6 columns, we need to display an asterisk on all cells in column 1, and we need to display an asterisk in column 6 for all row, which is here, and also we need to display an asterisk on the diagonal. So we need to specify their locations so that we put them in the condition. Here is the code. All what we have done, removed the print statement for the symbol asterisk and replace it by an if statement. And as you can see, this is if and else. Either we print a star or we print a space. So in cell row 1, column 2, we need to print a space. But in row 3 and column 3, we need to print an asterisk. So we need to put a condition in here, whether to print a star or an asterisk or print a space. So let us first locate these asterisks. By looking at all these asterisks at column 1, notice that on all rows, but if column is equal to 1, then we need to print an asterisk. So the first condition that we need to put is that if column equal to 1, then we need to print a star. Now let's go for the last column. Now for the last column, as you notice, we are printing on each row. So when column is equal to 6, also we need to print an asterisk. So we write or, and we write column equal to n. So whenever column is equal to 1 or column is equal to 6, then we need to print an asterisk. So in the first iteration, when column is equal to 1, it will print a star or asterisk because the condition is true. But when column becomes equal to 2, then the condition will be false because it's not equal to 1, it's not equal to 6. So it will go to the else statement and print a space. Now last is the diagonal. So how to locate the diagonal? So where is the diagonal? Here we have, this is the diagonal, row is equal to 1, column is equal to 1. Here is the second asterisk in the diagonal, row is equal to 2, column equal to 2. Third one, row is equal to 3, column is equal to 3. As you notice that when row is equal to column, we need to print an asterisk. So the last condition is that when row is equal to column, then we need to print also an asterisk. Now for any row or column does not satisfy these three conditions, it will go to the else statement and print a space. Notice that in this example, we are using the variable n that represents the size of the grid. The number of rows is equal to the number of columns, and these two sizes are saved in n. Sometimes we ask the user to enter this n. And this is why we are designing the nested loops using this n. However, for our example, if n is equal to 6, we have this diagram. So for the conditions, if we want to refer to the last row, then we are referring to n. If I want to refer to the last column, then we refer it by n. But if these rows and columns are fixed, then you need to put these constants inside the nested loops. For our next example, we would like to display the letter E, large letter E. And as you can see, we have a grid of size 5 by 5. For the grid, here we assume that the size is odd. So probably we could ask the user to enter only odd number. Why? Because we have, for the letter E, we have a middle line here we need to display. So to make the symbol consistent, so the number of rows before this middle line and number of rows after this middle line should be equal. So now we need to think about these asterisks, their locations inside this grid. Then we can look at this shape as if it consists of 4 parts. Now let's look first for the first part. Now for the first part, we need to display all these asterisks on column 1. So this is the first condition. The second part, we need to display all asterisks at row equal to 1. So this is the second condition. The third part, we need to display the middle line. And to display the middle line, we need to locate its locations. All the asterisks in the middle line, and the middle line can be found by dividing the number of rows over 2. So here we have 5 rows divided by 2, but remember we are dividing integer by integer, so the answer is integer. So it's not 2.5, it's in fact going to be equal to 2. But for 2, it's going to be row 2, but we need row 3, so this is why we add 1. So n over 2 is in fact integer division, so the answer will be integer. We add 1, then that will tell us where is the middle line. So the third part, or the third condition, is that we check for row. If it is equal to n over 2 plus 1, then we are referring to the middle row. Now for the last part is the last row. So for the last row, row is equal to n, and n is a variable, so it's equal to 5. And these are all conditions that we need to specify for the if statement. If any of these conditions is true, then we are printing star, otherwise we print a space. So this is how we can think of displaying shape of characters using nested loops, and the inner loop is responsible for either printing the character or printing a space. For practicing, let us design nested loops that will print the 2 shapes, the one in the middle and the one on the right hand side, using JGrasp. So let us have a look into the second shape first. As you notice that we are going to print in a grid of size 1, 2, 3, 4, 5. So we will assume that we will have odd number. The reason is that we are going to have a middle line of the @ sign. So therefore, we will ask the user to give us odd number. If the user did not give us odd number, we will try again and ask the user to enter a new value. Now, if we want to print into the grid, then we need to specify the locations of the @ sign. Notice that for printing, we need to print using the left diagonal. Also, we need to print and the right diagonal, and also we need to print in the middle line. So we need to specify their locations for each of these @ sign, so that when we write the nested loop, the if statement, we should put the condition for these characters. Now for the left hand side diagonal, or for the left diagonal or the main diagonal, we have seen an example on how to specify the locations of these @ sign. As long as the row equal to the column, then we are referring to an element in the main diagonal. Also, we have seen how to specify the locations for the characters at the middle line. And now we need to think about how to specify the locations for the right diagonal, which is this diagonal. And we will think about this while writing the code. So let us go to JGrasp and start typing. We are now in JGrasp. The first thing we need to do is to ask the user to give us the value of n. So we will define n as an integer, and we will ask the user system.out.println, and let us read on the same line by asking please enter a positive odd number or odd integer. Now, how to check for validity? One option is that once the user enter even number, we display a message and we quit the program. Another option is that we repeatedly ask the user to enter odd number if the user give even number. And to do that, we use a loop. The best loop for that is while loop, although we can use other loops like do while and for loops, but we need to modify them to work correctly. So how to use while loop for asking repeatedly for an input if it is invalid? We simply, first we need to read. So we will say n equal to read, which is the scanner name, dot next int, and then we need to check for this value, and we say while. Now what we want positive odd number. So how to check if the number is odd? We use modulus. And how to check if it is positive, if it is greater than 0. So put these two conditions and say n greater than 0, so it is positive. At the same time, that n, when you divide it by 2, it should give you remainder 1. So this is the condition for positive and odd. But remember that invalid if it is the negation of this condition. So therefore, you put the negation symbol in front of it. So that means if this condition is not satisfied, we will go inside the loop. We will display a message by saying system.out.println, and simply we will say invalid input, try again, question mark, and we are going to read from the same line. So we will remove len, and we will copy the reading because we need to read again for a new value of n. And this will give me the option to ask the user again if the input is invalid. After finishing from that, then we go to the next step, designing the nested loops to display the shape of symbols. So let us type now the nested loops. So we have for integer row equal 1, row less than or equal to n, and we have row plus or plus. And for the inner loop, we will have for integer column is equal to 1, also column is less than or equal to n, and we have column plus or plus. And in here we are going to write if statement, and we need to think about the condition where we are going to print the @ sign. So we say print @ sign, otherwise we are going to print a space instead. After finishing from the inner loop, remember we need to go to a new line, so we write system.out.println, and this is for new line. So let us think about what to write as conditions in a place of the question marks. For the main diagonal, the condition is row equal to column, and for the middle line, the condition is row equal n over 2 plus 1. And now for the right diagonal, we need to find an equation so that when row is equal to this equation, we need to print the @ sign on the right diagonal. To get this equation, consider the following analysis. For the purpose of the analysis, suppose the value of n is equal to 5. As we have discussed before, we need to print the @ sign on the right diagonal whenever the value of row is equal to 1 and column equal to 5. This is for the first row. And whenever the value of row is equal to 2 and column is equal to 4, this is for the second row, and so on. Since the condition inside the column loop, and you know that the column will go from 1 to 5. What is the equation that we need to plug in a place of the question marks so that when row is equal to 1, we need this equation to give us also 1 when the value of column is equal to 5. In other words, what is this equation? That when the value of column is equal to 5, it will be equal to 1. What is this equation? So that if the value of column is equal to 4, it gives me 2. So you can find this equation by trial and error. First, we need to suggest the value of this equation is 2n. And as you notice that n is going to be fixed. So whatever the value of column you plug into this equation, which is n, it will always give you n. So it's not going to give you 1, 2, 3, 4, and 5, and so on. So you need to write this equation involving the value of column as well, which is the variable column. So what will be this equation? Can we write n minus column, because the number is reducing, as you can see, or we write column minus n? But column minus n is not the right equation. Why? Because the value of column is increasing. See here, 1, 2, up to 5. And this equation will give you negative. So when column is equal to 1, then it will be 1 minus 5, so it is minus 4. So it will be minus 4, minus 3, so this is not the right equation. However, if you write n minus column, then what will be the values for n minus column? When column is 1, then it will be 5 minus 1. When column is 2, then it is 5 minus 2, and so on. So let us check this equation. As we mentioned before, what is the equation that if you substitute for the value of column in this equation, it will give you 1. So is this really the right equation? Let us find out. Now when column is 5, so 5 minus 5 is 0. So it's not equal to 1. Now when column is equal to 4, so 5 minus 4 is equal to 1. So it's not equal to 2. When column is equal to 3, so we have 5 minus 3, which is 2, which is not equal to 3. So as you notice that we have a shift. When column is equal to 5, then n minus column is giving me 0. However, I want 1. And when column is equal to 4, 5 minus 4 is 1, but I need the value 2. So in fact, the equation will be n minus column plus 1. So let us check this equation. Now when column is equal to 5, so this equation will be 5 minus 5, 0 plus 1, so it is 1. And when column is equal to 4, so we have 5 minus 4, which is 1, 1 plus 1, which is 2. And now if we check the last number, if column is equal to 1, so we have 5 minus 1 is equal to 4, and 4 plus 1 is 5. So this is the right equation. So in fact, if you put this condition, row equal to n minus column plus 1, then when row is equal to 1, then this equation will be equal to 1 only when column is equal to 5. So when column is equal to 1, it's not going to give you 1. When column is equal to 2, it's not going to give you 1. So this equation will be equal to 1 only when column is equal to 5, and this is what we want, and this is going to be the first at sign on the right diagonal. Now when row is equal to 2, then this equation will be equal to 2 only when column is equal to 4. And this is what we want for the second at sign on the right diagonal. So this is the condition that we are looking for printing the at sign on the right diagonal. So the condition for the right diagonal, it will be n minus column plus 1. Now we need to test our program. So we need to compile it first. So compile. We don't have any errors. Now for running, first we need to test it for validity. So let us assume that the user did not put odd number. Suppose for example 8. So it will say invalid input. Try again. Suppose the user did not put positive number. Let's say minus 5. And again it will say invalid input. Try again. And now let us try 5. As you can see, it is printing the shape that we are looking for. Let us increase the value of n. And whenever we say n, let's say for example 10. And 10, since it is not an odd number, it will say invalid input. Try again. But let us put a value of 11. And this is the symbol that we need to print when the value of n is equal to 11. For the last shape, we will leave it as an exercise. You need to find conditions for printing asterisks in the corners as well as in the middle of the shape.